One line of bad input and your entire program just dies. I'm Kai. Think about a file that does not exist, or dividing by zero. Without a plan, Python quits and throws a scary red wall of text at your user. With a plan, your program notices the problem and keeps running like nothing happened. That is what we are building today. Think of an exception as an alarm going off while your program is running. Something went wrong right here. To raise an exception means you pull that alarm yourself on purpose. A try block is where you put the risky code you're watching closely, and an except block is the safety net waiting underneath it. Try means attempt, except means catch the fall. Imagine a tightrope walker. The walk itself is the try block. It might go fine or it might not. If they fall, a safety net catches them. That is the except block. And no matter what happens, fall or no fall, the crew rolls up the mats afterward. That is finally. It always runs success or failure. Here is the simplest version. Inside try, we attempt to turn the word hello into a number, which cannot work. Python raises a value error, and instead of crashing, our except block catches it and prints a friendly message. Notice the program just continues on after that. Nothing exploded. Sometimes more than one kind of error could happen. So you stack up multiple except blocks, each one aimed at a specific problem. Python checks them from top to bottom and runs the first one that matches. Here, dividing by 0 triggers a zero division error, so only that first except block fires. Here's the trick with else. It only runs when the try block succeeded with no exception at all. This is handy because it separates the risky part from the part that should only happen after success. In short, try is the attempt, except is the failure path, and else is the celebration when nothing went wrong. Finally is the one block that always executes, no matter what happened above it. Whether the try succeeded, failed, or even if you returned out of a function early, finally still runs. This makes it perfect for cleanup work, like closing a file or releasing a connection. In short, finally is your guaranteed last step. Let's picture the whole flow as a pipeline. First you try the risky code. If it fails, except catches it. If it succeeds, else celebrates. And no matter which path you took, finally closes things out at the end. You will not always need all four, but knowing the order helps you reason about your code. You are not limited to catching errors. You can create them too. Here, if someone passes a negative age, we raise a value error ourselves on purpose. This is you telling Python, this situation is invalid. Stop right here. It is a way of enforcing your own rules about what counts as valid data. Python's built-in exceptions are like labeled evidence tags. Each one names exactly what went wrong. Parse text, where a number belongs, that's a value error. Mix a number and a string like they're compatible, type error. Ask a dictionary for a key it doesn't have, key error. Reach past the last item in a list, index error. Learn these 4 names, and your error messages start telling you exactly where to look. Here is a mistake I see all the time, and honestly I made it myself early on. Writing a bare except with no error type and then just passing silently swallows every single error, even ones you never expected like typos in your own code. It looks like your program works, but it is actually hiding real bugs from you. Always name the specific exception you expect so surprises still surface. A close cousin of the bare except is catching the generic exception class. It technically works, but it groups totally different problems under one vague message. You might wonder why that matters. Well, imagine a network error and a typo, both getting the exact same unhelpful print statement. Being specific means your error messages actually mean something. There are 2 styles here. You can check conditions first, like asking if a key exists before using it, or you can just try the operation and catch the failure. Python culture leans toward try and accept. It is often called asking forgiveness rather than permission. My honest opinion, for anything involving files or network calls, try except is usually cleaner because checking first does not even guarantee the operation will still succeed a moment later. So let's wrap this up. Try holds the risky code, except catches the specific failure you named, else runs only when things went well, and finally always runs to clean up. You can also raise your own exceptions to enforce rules in your own programs. Get comfortable with this and your code stops crashing and starts handling problems like an adult. Clean. You made it to the end. That's the hard part. Liking and subscribing is easy.